Hi, Algebra 2. Today we are going to look at 2.5 using linear models. Our learning target today is to write linear equations that model real-world data and to make predictions from the linear models. We are going to use our graphing calculator quite a bit today, so if you do not have your graphing calculator handy, you can pause the video and grab that, or you can log in and get the online calculator. Two concepts we're going to look at today. First, a scatter plot is a graph that represents two sets of data graphed as ordered pairs, and then we try to identify a relationship or trend between the data. The correlation is the strength and direction of the relationship between the two sets of data. Once the data is plotted, we can start to look at the relationship between the data. So there's two different directions that your data could go, positive or negative, and then we could classify that as strong or weak, and then we could also have no correlation. So first, strong negative correlation is when we see our data points start to line up tight close to a line and head in that negative slope direction. So an example of that could be the cost of heating your house and exterior temperature. As the exterior temperature outside increases, the cost to heat is going to decrease, and sometimes you don't even need to run your heat. And then a weak negative correlation would be the points are a little bit more spread out. No correlation means that there is no relationship with the data. We just have some lines plotted, points, plotted everywhere. Weak positive correlation, our lines are not bunched, or our points are not bunched together. Strong positive correlation is when our points are bunched together towards a line. So an example of this could be the amount of calories you burn compared to the time that you spend exercising. So as the time increases, the amount of calories that you burn is going to increase. Our goal today is to create a line of best fit with our calculator. A line of best fit is the most accurate trend line using the lin/reg function on a calculator. And then we're also going to use the correlation coefficient to indicate the strength and direction of the correlation. The closer that r is to 1, r is the variable that we use to represent the correlation. The closer r is to 1 or -1, the stronger the correlation. So when you're working with data, it can be a little messy. The points, as you can see above, don't always line up perfectly in a line to show a trend, but we can use the line of best fit to start to make predictions, start to extrapolate our data beyond the data that we were given. So we are first going to start to take out our calculators, and we have to set up a couple things on your calculator in order to do these operations. First thing we have to do with our calculators, we have to turn on the correlation coefficient. To do that, you can go to your calculator. You need to hit the second and then go down to the 0 where it says catalog. And we are going to scroll down, or you can just hit any of these green letters. We're going to scroll down to the D's. So you can hit this D to get down to the D's, and we're going to scroll to diagnostic on. So we're going to keep going. So this is the one we want, diagnostic on. When you hit enter, it'll bring you back to your main screen. Diagnostic on, hit enter again, and it should say done. That's going to turn on your R value, your correlation coefficient. In problem 1, we're going to take the data and create a line of best fit. So we'll get our calculator out here in just a second. So the table shows the median home prices in New Jersey. What is an equation for the line of best fit that models the relationship between time and home prices? Use that equation to predict the median home price in 2020. And then what is the correlation between the year and median price? So as we kind of glance at the data, we can see as the years go up, we can see our home prices are also going up. So we kind of have an understanding of that with inflation and things back in the 1940s did not cost as much as they do now, for sure. So we can kind of see that happening with these home prices. So next thing we're going to do is we're going to take out our calculator. So go ahead and get that out. So hopefully you've already turned your diagnostic on, so you're ready to go. So what we're going to do is we are going to start to enter in our data. And to do that, we're going to hit this stat button. To make our calculations a little simpler, we're going to think of as we're going to think of 1940 as year 0 when we started to keep track of these home prices. And then every 10 years after that will represent with 10, 20, 30, and so on. So we've adjusted our years, and anytime we have data dealing with years, we are going to think of that first data point, we're going to think of as 0, and then we're going to write the years, the amount of years after that time as the rest of our data. So when you're in Stat, you're going to hit Edit, and you're going to be presented with this table, L1, L2, L3, so on and so forth. We have 2 groups of data, so we're going to use the L1 and the L2. So what you're going to do next is you're going to enter in the data. You can just hit your number and hit enter, and it'll automatically jump you to the next position in your table. So go ahead and enter all your data. Once you have entered all your data, your calculator is now ready to calculate a line of best fit. So that's what we are going to take a look at next, is making that calculation. So to make the calculation, you're going to leave this table. So to do that, you're going to hit second quit, and that's a good key sequence to use to get out of something that you're working on. If you hit clear, sometimes you delete the information that you've been working on, so hit second quit to leave. Then you're going to hit stat, and now we're going to go over to calculate. So all I did was arrow over. We have menus up above. We're arrowing over to calc. Then we're going to go down to number 4, linear regression, and we'll hit enter. So a regression is a statistical measurement. So we're going to measure a linear regression. Linear means line. So we're going to measure a line that's going to match this data over here. Now you want to double check your X list. That's our amount of years, is L1. Our Y list is L2. There's our median prices. Those are what you just put in the table. Frequency list you can leave blank. And we're going to head down to this store regression equation. So once we find this regression, this measurement, we are going to store it in our calculator. So that's what we're going to look at next. To store this, you're going to hit alpha, trace, and you're going to select the Y1. This is going to put this into your Y equals so that you can use this equation that you're going to create in any calculations that you need. So again, that was alpha, trace. Now we hit Y1. Now we're ready to hit calculate. When we calculate, your calculator now is going to give you a couple of data points here. So our linear regression is going to be in slope-intercept form. So this is y equals ax plus b. A is your slope, b is your y-intercept. Your A, 2507, that represents your slope. Your B, 35414, is going to represent your y-intercept. So there would be my linear equation representing this data. Now, if you're unable to store the regression equation, that's okay. We can just take this equation and you can put it into your y equals. But if you were able to store it into your y equals, you will see it now right here. So now it is stored in your y equals. So if you missed what I did there, I just hit y equals. Now I have that equation stored. This is helpful to store this equation because now we can use this equation to predict in the future. To do that, we're going to go second table. So 0 years, that would be 1940. If I scroll down, 2020 is going to be 80 years after 1940. So I can go down to where 80 years is, and that's going to be my median home price in 2020. So if I look there, sometimes the numbers don't show up. If you just scroll over, you'll see the number represented down here. Here we can still see it. So my median home price in 2020 is going to be $235,985. The last thing we need to do is we need to look at the correlation. So what is the strength and what is the direction? So we're back at the main screen. I just hit second quit to get out of my table. And if you hit the up arrow, you can go into the past of calculations you've made. So up in our history, there was the calculation we made right there, linear regression. Let's hit enter on that. And pops up our data again. So we're looking for this R value. So our R value is 0.91. So from the notes, we looked at the correlation coefficient. The closer this is to 1, the more accurate it is. So 90, 0.91, 0.92 is pretty accurate. The other thing is this R value right here is positive. That means that we do have a positive correlation. Something as we kind of glanced at the data, we could see as the years increase, so does that median home price generally increases. So this, our R value would be 0.92, let's call it, and we'll say that's a strong positive. There are a few advanced things I want to show you on the calculator. If you want to see these, you can stick around. If not, you can skip ahead a couple minutes to the next problem. So some advanced things that we can do is we can graph scatter plots on our calculator. So next thing that we can do is take this data that we made and we can make a scatter plot. To do that, you're going to hit second stat plot. This is going to open up all your scatter plots that you can make. You're going to hit enter on plot 1. We are going to make sure it's turned on. So anytime it's black with the white lettering, that's going to be selected. Our type, that's a scatter plot. We're using L1 and L2, and we'll just say that we'll use blue there. Okay, so we've got our scatter plot turned on. You can hit second, quit. Then we're going to go to zoom. So zoom sets your window on your calculator, and we're going to go down to number 9. Zoom 9 is zoom, and it's going to take whatever your statistics are in your table and make a window so that you can see those. So we'll hit zoom stat, hit enter, and we can start to see our scatter plot. So here's our 1940, 50, 60, 70, all the way up, and then we've got our trend line cutting through there as well. So there would be just some advanced things you can do with these scatter plots, and there's going to be our picture. Now the thing is, now your window is set to this. To get back to a regular window, you're going to hit zoom and then number 6, which gets you back to the standard 10 by 10 window. So sometimes you're messing around with your window to get things to fit in correctly. To get back to that standard window for when you're graphing something else later on, you're going to hit zoom 6, and that's going to get you back to that standard window. So in problem 2, we are going to look at the cost of a movie ticket compared to the year. And again, we took the years 1995. We're going to put as year 0, and then each year after that is in intervals of 2. So we're going to go 2, 4, 6, all the way to 12 years after. It would be 2007. So we'll find the equation for the line of best fit. We'll practice that again on our calculator, and then how accurate is your line of best fit. And then based on your linear model, what would you expect to pay for a movie ticket in 2025? So how accurate is your line of best fit? That's where we're going to look at that correlation coefficient. So what is R going to equal? You probably have your data from the last problem. To get rid of that data, you got to be really careful here. You're going to highlight the list. So I got my black with my white lettering, and you're going to hit clear. That's going to clear all of your numbers out. Then you hit down arrow, go over to L2, go up, hit clear, hit down arrow. That's going to get rid of all of that data from the last problem. So now that you have your data entered, we can start to figure out what our line of best fit is. So we're going to hit second, quit. We're going to hit stat. You're going to arrow over 1 to calculate. We're going to go down to number 4, linear regression. And same as before, we're going to go down to first make sure our X list, Y list are set. Store regression equation. You can hit alpha trace, select Y1 to put it into your Y1, and then you can hit calculate. So there's our data. Our slope is about 0.217, so we'll say that's about 22 cents, and then our B value is $4.26. So we'll first write our equation, and our equation about 22 cents per year. Ticket prices goes up. Our y-intercept is about 4.26. Next, we'll take a look at our R value. So our R value is about 0.996, so we'll round that up. So our R value is about 1. So how accurate is our line? Our line of best fit is very accurate. So our correlation coefficient is 1, which also means I have a positive correlation. So as the years go up, so are my movie ticket prices. Lastly, I want to show you another way that you can predict in the future about where your ticket prices will be. So we want to figure out what is the ticket price going to be in 2025, which is 30 years after our data started. So to do that, we can go into table set. We're going to hit second table set, Down where it says independent, we're going to go to ask. And then we are going to go to our table. Now you'll notice your table is blank. And to get to table, I hit second graph. Our table is blank. We want to figure out in 2025 what is the price of a movie ticket. So 2025, that would be a X value of 30, because that's 30 years after 1995. So I'm going to type in 30, hit enter, and it's going to give me my price for my movie ticket, which is right there. So about $10.80 is what I would expect to pay in 2025. So there would be my result for all of my answers. So I get a equation of 22 cents times x plus $4.26. R value is 1, and then the price of a movie ticket in 2025 would be about $10.80. So there is our lesson 2.5, which we start learning how to use the calculators and then some of the advanced things with calculators that will be helpful later on in your math careers. But that is lesson 2.5 with our learning target of finding the line of best fit. You can go ahead and start your practice. Good luck.